Chemical equations from names. What we need to be able to do now is, if we're given the names of the reactants and the products, we should be able to write the formulas for those reactants and products and then balance the equation. So let's just put a little hint up here on the top so that we remember. Remember that our Hankel-Brith elements are diatomic molecules. So if we find any of these, hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, or fluorine, by themselves and not in combination with another type of atom in a compound, they will be diatomic. Okay, so we're going to react magnesium with hydrochloric acid, and we're going to produce hydrogen and magnesium chloride. So magnesium is Mg. When we look up here, it's not diatomic, so we can write it as just Mg. And we're going to react it with hydrochloric acid. We know that acids contain hydrogen as their positive ion. The prefix hydro tells us that there's no oxygen in the negative ion. The chlor tells us what that negative ion is. Hydrogen is a +1, chloride is a -1, so our formula for hydrochloric acid is HCl. When it says produces, we'll put an arrow. Hydrogen, we go back up here, is a diatomic molecule, so we have to write H2. And our other product is going to be magnesium chloride. So MgCl. We look on the periodic table, the charge on magnesium is a 2, and the charge on chloride is a -1. So now we've got our formulas written, we have to balance the equation. 1 magnesium, 1 magnesium, 1 hydrogen, 2 hydrogens, so that'll give us 2 hydrogens on both sides. Now we've got 2 chlorines and 2 chlorines. So we have a balanced equation. We also have an element reacting with a compound to give us a different element and compound, so it's a single displacement reaction. So let's look at another problem. Calcium hydroxide reacts with lithium chloride to produce lithium hydroxide and calcium chloride. So calcium is Ca, hydroxide is OH. The periodic table tells us the charge on calcium is a +2. We know that hydroxide is a -1, so the 2 from the calcium drops down here. Lithium chloride. The periodic table tells us that lithium is a +1 and chloride is a -1. We're going to produce lithium hydroxide. Lithium is a +1, hydroxide is a -1, and calcium chloride, +2, -1. Now we're going to balance. 1 calcium, 1 calcium, 2 hydroxides, 1 hydroxide, so we'll put a 2 to balance our hydroxides, 2 lithiums, 1 lithium, 2 chlorines, 2 chlorines. So we have a balanced equation. And we've got a compound reacting with a compound where the calcium displaces the lithium and the lithium displaces the calcium, so we have a double displacement reaction. We're going to decompose copper 2 oxide into copper and oxygen. And remember that copper is multivalent, so that Roman numeral tells us the charge on the copper ion. So CuO, copper is a +2, oxide is a -2, and those 2's get simplified. We're going to decompose it into copper, which is not diatomic, so it's just Cu, and oxygen, which is. So now we need to balance our equation. 1 copper, 1 copper, 1 oxygen, 2 oxygens. So if we put a 2 in front of the copper 2 oxide, that'll balance our oxygens. And then we'll need to put a 2 in front of our copper to balance our coppers. Aluminum and iron 3 oxide produce iron and aluminum oxide. So Al, aluminum is not diatomic. and iron 3 oxide, so Fe for iron, O for oxide. The charge on our iron is a 3, oxide's a -2. So the 3 from the iron will come down here, and the 2 from the oxide will come down here. The aluminum, since it's on the left side of the staircase, is going to displace the left-hand ion out of the compound. We're going to produce iron, which is not diatomic, and aluminum oxide. Aluminum from the periodic table is a +3, oxide is a -2. So now we need to balance. 1 aluminum, 2 aluminums. So our aluminums are balanced. 2 irons, 1 iron. So our irons are balanced. 3 oxygens, 3 oxygens. So our oxygens are balanced. Now let's look at a combustion reaction. And we will eventually be able to write formulas for hydrocarbons, but in this case we're told that butane, which is the stuff in lighters, is C4H10. And it tells us that it combusts in air. Well, air is a mixture. We have to know what it is in the air that the butane is reacting with. And in combustion reactions, we're looking at oxygen. And it tells us that we're going to produce carbon dioxide and water, but it doesn't necessarily have to tell us that, because we know that combustion reactions produce carbon dioxide and water. We have 4 carbons, only 1 carbon. So we'll balance our carbons. We have 10 hydrogens, we have 2 hydrogens. 5 times 2 will give us 10. We've got 4 times 2 is 8, and 5 plus 1 is 5. That's going to give us 13 oxygens on the product side, and we can't put a whole number here to get 13. So if that happens, we're going to double everything. We'll make this a 2. This will become an 8, carbon's still balanced. This will become a 10, hydrogen's still balanced. But now we have 16 plus 10, or 26 oxygens, and we can get 26 oxygens on the reactant side. Now the last thing we have to do for writing and balancing equations is sometimes we're just given the names of the reactants and we have to figure out what the products are. So we have to identify the reaction type, follow the pattern for that reaction type, and predict what our products are. So in this case we have magnesium, which is not diatomic. We're going to react it with nitrogen, which is diatomic. And the only thing those two elements can do is combine together. So we have a synthesis reaction. We're going to produce magnesium nitride. Magnesium is a +2. Nitride is a -3. Our nitrogens are balanced, but to balance our magnesium, we'll have to put a 3. Copper 2 oxide is decomposed into its elements. So we've got copper and oxygen. Copper's a +2, oxide's a -2, so we simplify that. It says we're going to decompose it into its elements, so it breaks up into copper and oxygen. Remember that oxygen's diatomic. So to balance the oxygens, we'll put a 2 in front of the copper oxide. And then to balance the coppers, we'll put a 2 in front of the copper. Let's say we've got chlorine and potassium bromide. Chlorine's diatomic, so Cl2. K for potassium, Br for bromide, +1, -1. Alright, so we're looking at an element in a compound, so we're looking at a single displacement reaction. But we have to decide whether it's the potassium or the bromine that's displaced by the chlorine. And the easiest way to do that, again, is to just look at the periodic table. Since chlorine is on the right side of the staircase, it's going to displace the right-hand ion out of the compound. So we're going to displace the bromine out of the compound, and it's diatomic. And we're going to replace it with the chlorine, and we've got a +1 and a -1. Now really the chemistry terms behind that is chlorine forms a negative ion, so it's going to displace the negative ion out of the compound. You can't end up with two negative ions in a compound, they'd repel each other. But again, that trick of what side of the staircase the element's on will work for which ion it displaces out of the compound. Calcium hydroxide and sulfuric acid. So calcium is Ca, hydroxide is OH. The periodic table tells us calcium is a +2, and we know hydroxide is a -1. So there's our formula for calcium hydroxide. Sulfuric acid, acids have hydrogen as their positive ion. There's no hydro, so we need a polyatomic ion for our negative ion. Ic goes to 8, so we need sulfate. And sulfate's SO4. Hydrogen's a +1, sulfate's a -2. So now we have two compounds. That means we've got a double displacement. So the calcium's going to displace the hydrogen and form calcium sulfate. +2, -2, that gets simplified. The hydrogen is going to come back and displace the calcium, and we're going to produce hydrogen hydroxide, which is really water. You can write it as H2O, you can write it as HOH, whichever way you want to do that. So 1 calcium, 1 2 hydroxides, 1 hydroxide, so that'll balance out our hydroxides. 2 hydrogens, 2 hydrogens, 1 sulfate, 1 sulfate. So a balanced double displacement reaction. Iron 3 chloride and sodium hydroxide. So iron is Fe, chloride is Cl, +3 -1. Sodium hydroxide, +1 -1. Two compounds makes it a double displacement. So our iron will displace the sodium and will produce iron hydroxide. And since it started out as iron 3 on the reactant side, it stays as iron 3 on the product side. The sodium will displace the iron and will produce sodium chloride, +1 -1. 1 iron, 1 iron, 3 chlorines, 1 chlorine, 3 sodiums, 3 sodiums, 3 hydroxides, 3 hydroxides. A balanced double displacement reaction. Our last one, methane. Well, we can't write a formula for that yet, although we've mentioned it. CH4. And this time it just says a combustion air. So we have to remember that it's actually oxygen in the air that's used in a combustion reaction. And we produce carbon dioxide and water as our products. 1 carbon, 1 carbon, 4 hydrogens, 2 times 2 gives us 4 hydrogens. We've got 2 plus 2, 4 oxygens. So 2 times 2 will give us 4 oxygens.